Hi, for this lesson, we're going to data handling, measuring foreign frequency. Now, the data handling, measuring foreign frequency is actually covered in grade 10 and grade 11. We don't actually have official classes on grade 12. The first thing we want to look at is with regards to just having a list, having data as a So we have what we call the tendency, measures of tendency of the data. And that is what we want to have and look at now. Measures of single tendency of data, which is in A. First thing we have is the mean, which is the sum of all the values divided by the total number of the values. You can see the equation here, the sum of the values divided by the total number and the mean. The next thing we're looking at is the median. The median is the mean value when all the values are placed in ascending or descending order. If the total number of items you have is an odd number, then the median is going to be in the middle. But if it's an even number, then what happens is that you need to add the 2 in the middle and divide by 2 to get the median. For the mode is the data that occurs the most. So if you have a data that occurs the frequent amount, the same amount, also you have just maybe 2, you'll be at 5 model. If it's more than 2, you'll have a multi-model, and it is possible for you to have no model in that is not repeating. So then we're going to look at still looking at the central tendencies of measure with regards to root or frequency tables. Right? So the frequency tables, we will have frequency series, and when we are looking for the model, we look for the one with higher frequency. And when we're looking for the median, one way to find the median is to list all the values in the frequency of the table in order of the size, and another is to work directly with the table. And we're going to make an example of how we find that mean. Let's make an example. Actually, let's just use this table over here. So this is the number of siblings that a person would have, and this is the frequency of the number. So here, let's see what the frequencies get up to. We have 2 plus 3 plus 4 plus 1. 2 plus 3 gives us 5, gives us 5, and then right number. The chances are that the frequency should not somewhere. So if we look at these, they only contain 2, and then the 5.5, which is in 6, should be in this region. It should be here, because here the data, we have 5 of our data sitting on this side, 5 of our data sitting on this side. That means when we just click, we can click in terms of 2 because it's closer to 5 here. So then the median says that the middle number of children the family is going to have the number of siblings, especially then we also have the mean. We say here one way to find the mean is to list all the values in the frequency table and up those values and divide them another way to do it is to write directly with the table using the formula that says the frequency multiplied by x value, where is the frequency, x is the data, and let's look at the way we did it. So for method 1, we just added up inside again. So 0 should up twice, there's 0 from 2. 1 should have 3 times, there is 2 should have 4 times, there is operation of only once, there is frequency, so it's 7. Let's see when we go answer. One sibling, we just write the frequency. Another way you can do it is using the table here. So you're just multiplying the frequency with the auxiliary multiplying with the 5, and then dividing by 10. So we've worked with now just frequencies. Now we want to work with the frequencies. So when it comes to data, we have different types of data. We have discrete data, which consists of the numerical values that are found in the counting, and then given as percentages over here. We have continuous data, and this consists of the numerical values that are found by measuring, and we have over here, and we have data, and this is consists of description using names, and then given as percentages over here. Now, if you look at the percentage tendencies of these indicators, for the mode, you will have a modal interval. So you would look at the greatest frequency, and the greatest frequency would be the modal. Then for your median, you can't necessarily find the median value from the table. You can find the trust interval that contains the median, and then find the approximate value of the median that contains Okay, so now let's look at this. We can see that in total we have, in terms of the frequency, we have 40. That means the median must lie between 21 and 20 value. So now let's see where this 21 and 20 value is going to lie. So we're going to look at our table here and say, okay, from there to there, it's just 3, from there to there, it's 14, and then from 14 to there, so 14 plus 9 gives us 23. So now we have passed that 20 to 21 region that we were looking for, so that means that the interval is here. Between 30 to 40, we'll find our median. So then now, the middle number of 30 to 40 is, the middle number of 30 to 40 is then going to be 45, making 45 our median. The next one we have is the mean, and the way to estimate the mean is first, you find the midpoint of each interval to represent each class. Then you multiply by the midpoint by the frequency in order to work out the estimated an estimation of what the total should be for the class. And then these values are added up together to give you the total value. So when you do this, then you divide and multiply the n, which is the total frequencies. So let's look at those data again. So you can see here that I identify the midpoint. They multiply the midpoint with the frequency to sort of estimate. It's sort of like they are estimating. And then when they're done with this 1,420 then what we have, well, we can use is we have our cutoffs are these 3 values Q1, Q2, and Q3 that divide the center into 4 approximate equal parts, as you can see from the table over here. Now, the new cutoff here is it's going to lie between 25% of the data, which is less than the Q1, and 75% of the data, which is the more. And we have our median, which has 50% of the right, 50% of the left, and our Q3, which has 25% of the data on the right, and 55% of the data on the median just divides it into into two halves. So the equation that we normally use here to find out the answer says 1 plus 1 over 2. And then this one here divided into 4 quarters, so we just say 1 over 4. This is your Q1. This is just a total position. When you have the position, then you put it. Okay, this then allows us to come to the 5-number summary for the data. We would like to find the minimum value of our data set, Q1, and the median, which is Q3, upper quartile, which is Q3, and the maximum, which is Q4. The maximum, which is just the maximum of the number. And this would then allow us to draw the risk graph, where we have the minimum value here, Q1 over there, Q2 over there, Q3 over there, and the maximum value over there. Okay. So note that if the mean and the median of the data set are unknown, the samples we can determine. If the difference between the median and the mean is less than 0 equal to 0, we can say that the distribution is symmetrical. If the mean and the minus the median is greater than 0, we will say that it's positively skewed. And if the mean minus the median is less than 0, then we will say that the distribution is negatively skewed. So this one will be somewhat equal to 0. Then we have percentiles. Percentiles work in the same way as the Q2, Q3, so the 50% here, 50% there. And the most important percentiles we use is the median, the lower quartile, and the upper quartile. The median is the 50% quartile, it means 50% high, means 50% nice on the upper side and the upper side. And the lower quartile, which is 25%, it means that 25% of the data is below this level. And then the upper quartile, which is the 70th percentile, it means that 5% of the data lies below that. Then we're going to look at the measures of dispersion, which looks at how dispersed out our data is. We'll start with the range where we just say the range is the largest value minus 1 minus 2. Now there is some limitation which you take into consideration when you look at the range. The first one is that it does not take into consideration about the distribution of any piece of data except the smallest and the largest. The next one is that when the data is given in a good frequency table, the range cannot be moved, unfortunately. The next one we have the upper quartile range. This is the difference between the upper quartile and the lower quartile. The next thing we focus on is your O-GIF, frequency, and your cumulative graphs. So for your frequency tells us how many items are in the data. Here's an example. This is part of the census of school, 179 specifically to find out the type of training that we give the results. Additional audience 7 house with separating out 76, 10 to 1, and it's only the 6 consistent frequency. And you can draw a polygon in terms of the frequency. How you can represent it in terms of the cumulative pattern, which we do forget. And again, we should be able to just so for the cumulative is just as the frequencies. So here the first frequency is 7, the next one will be 7 to 6 plus 7, the next one will be 83.1, and the last one would be the 86 million. So we can shape between this graph over here. Right. Okay. And once you have that as graph, then here you have you should be able to find 50% of quartiles, you will find what is 50% of 170. Normally we use not best but numbers, so it's kind of hard to show using these letters. But again, if you check out some past papers, you'll see how we can execute. The last one we want to talk about is your standard deviation and the variance. Now, the standard deviation tells you how spread apart and how relatively trusted your data is. The data set with more data that is going to be near the mean, with less, we'll say that it's less spread and has a smaller deviation. The data set with a lot of data far from the mean, which will have a greater spread and have a large standard deviation. For example, what they can do is actually give you the standard deviation, right, and make you just calculate the mean. And then they will ask you, where does your standard deviation for, let's say, maybe let's say something like that, right? And then we want to know which data sets fall between the standard deviation. So what you want to do is have the minimum and you have the maximum, and then you can say 5 minus 2.5, and then here you say 5 plus 2.5, and the minimum and the maximum, and you will see, okay, this is the data that follows one standard deviation from the line, and then you can say, okay, these are the numbers, so you can have that, so they can say, okay, these are the numbers that follow so that's mostly when it comes to the standard deviation. Please go ahead and look at the YouTube videos that we have on the site, which is going to YouTube searching for Fundamanje, where you get things how people examine how each patient is specific.